Hey guys, this is Carrie, and this is the answer key video for homework number 8. So you invest $12,500 in an account that earns 15% yearly interest. If interest is compounded monthly, write the equation for the value of the investment after 2 years. So there are a couple ways that we've been doing these problems, but I think my preferred way is to use fractions. So to calculate the monthly percent, we take the yearly percent and we divide that by 12. This gives us a not so friendly decimal, or maybe not so bad decimal, but sometimes it's a not so friendly decimal. And so what we can think about is using the fraction version of this in the formula. So we could say A of t is equal to, starting at $12,500, we're going to be taking the monthly percent that it increases by, and because it's increasing by this percent, we'll have to take 100% and add whatever it's increasing by to it. So 100% becomes 1 when you convert it from a percentage to a number. And then plus 15% becomes 0.15 when you convert it from a percent to a number, over 12, because we're taking that 15% and dividing it into months. And then because we're compounding it every month, it's going to be compounded 12 times as frequently as though it were years, so this will be the 12t power. For b, if interest is compounded daily, write the equation. So A of t is equal to 12,500 times, this is going to be the exact same formula, but the only thing that changes is because it's daily, we're splitting it into 365 chunks instead of 12. And it's going to be compounded not 12 times as frequently, but every day, so 365 times the number of years. For C, you're going to be putting these formulas on your calculator and then determining how much more you would make. It does make a difference how we compound our interest, so please take a look at this one on the calculator. Today in class we learned about a famous number, e, but before we get to e, let's talk about some of the other famous numbers in math. So one of those numbers is pi, and that's approximately 3.14159, and then an infinitely long non-repeating decimal. This year, we also learned about the number I, and the number I was the imaginary number. And this one we couldn't write as a decimal. We had to write it as the square root of -1. And no decimal would give us -1 when we multiply by itself, so I was a brand new kind of number called an imaginary number. E was actually more similar to pi when we learned about today. E is a decimal that that goes on forever without repeating. And E is approximately equal to 2.71828. And then there's no pattern to the digits, so it is an irrational number just like pi. Notice that we're talking imaginary for I, and then these two are irrational numbers. Okay, so I think you guys can answer part 3 based on what you just heard. For part 4, we're going to be writing the discrete version and the continuous version of each of these. So the discrete version is the old version. So this is going to be the one that's structured like A of t is equal to 1,000, the starting amount, times 1 plus. It's going to go up by 12% every year, so that would be 0.12 as a decimal. And that's going to be to the tth power. Now this part we often write as 1.12, and we often think about doing that in advance, where we say 100% of what we had before plus the additional 12% would make this 112%. But you could write it as either 112%, 1.12, or keeping them separate, and all of those are correct. This is more similar to what we were doing up here with the fractions, though, and so I like this representation for today's assignment. For part B, we want the continuous formula, and this always has e in it, so this is the a equals p e to the rt formula, or apert as a lot of students call it. So here this one will be a of t is equal to p times e. Now r, you don't have to worry about including this 100% that we included before. We saw today in class when we were deriving this equation that 1 plus 1 over x to the x power, this came from the 100%, and this whole thing became e. So that 100% is actually incorporated in the letter e here. And so we end up with r being just 0.12, not 1.12, and t is t. For question 5, very similar. This one is going to be the number of bacterial cells in a specific type in a person's body is 70,000. After taking an antibiotic, wow, there's some grammar mistakes here. After taking an antibiotic, the number of bacterial cells decreases by 23% each day. So that'd be something like A of t is equal to, it would be 70,000 on the first day, and then here we'd say 100% minus the 23% that we're losing. But in this homework set, we've been thinking about, rather than actually doing the subtraction, leaving it as two separate terms. So the 100% becomes 1. This becomes 0.23. And then this is all to the tth power. And that would be the same thing that we did before, where we calculated this to be 77% by actually doing the subtraction. But leaving them separate here, I think, is more similar to what we've been doing in the other problems. For a continuous one, we've got A of t is equal to p e to the rt. So 70,000 times e to the r, which decreasing by 23% is going to be negative 0.23 t. For 6, the number of bacteria that grow in a petri dish is initially 500. Each minute, the population increases continuously by 4% of its previous value. So because this has the word continuously, we know that our formula will have to be A equals P e to the RT. This time, the variables are a little different. It's B of t for bacteria as a function of time is equal to P, 500, times E to the R. And it's growing, so it's positive. But notice that we don't include the 100% for this R value. And then T is T, the time. For B, use the model that you created in part A to determine the nearest integer, the number of bacteria present after 50 minutes. So for this one, we're just plugging in 50 minutes to our formula. And you can use any calculator to do that, so Desmos can handle it. So 500 times e to the RT, so 0.04 times 50. So 26,020 bacteria. Cool, we got it right. And it said rounded to the nearest integer, so you want to make sure that you have a whole number answer. Alright guys, I hope you found this video helpful, and I'll see you in class on Monday, where we'll learn about more about E. Bye!